So yesterday we were started with the physical pharmacy, and from that physical pharmacy we have seen the this important points for GPAT Niper DI Pharmacist from the chapter Micromeritics. So I would like to revise in a 5 minute what we have seen. So we have seen what do you mean by micromeritics. That is the study of particles, powder particles in the micron size, right? Okay, because uh, this if you did not study the particle size and all that, so that will have a effect on your formulation, right? So particle size distribution, how to characterize the particle. So characterization of particle is done by using particle size distribution and powder, right? Or powder size, shape, volume, density, surface area, porosity, and other associated properties, right? So you know 1 micron is equal to 10 raised to minus 3 millimeter, or same 1 micron is equal to 10 raised to minus 6 meter. 1 micron is equal to 10 raised to minus 9 nanometer, right? So these micrometers are involved in the release of release and dissolution of drug. The study of micrometrics is involved in the release and dissolution of drug, adsorption of drug and its action, right? We have seen physical stability also, uniformity of content we have already seen, right? Particle size and particle size distribution and diameter, they are known as the fundamental properties of powder, and other properties which are derived from, or which are nothing but the based upon the particle size and particle size distribution diameter. They are nothing but the derived properties. So what are they are nothing but the volume, density, porosity. They are the derived properties of water. इसके ऊपर क्वेश्चन आ चुके हैं already. Characteristic of particle can be characterized by its size, shape, volume, surface area, density, porosity, and flow properties, right? We have seen what do you mean by, what are the different shapes of your particle. Particle may be spherical in shape, or okay, spherical in shape but smooth spherical. Surface will be smooth. Spherical, spherical, irregular. Okay, then rounded, then angular, elongated, irregular, acicular, angular, and dendritic. Okay, now sphere means what? So sphere is nothing but the ideal particle. जो circular particle तो उसको ideal particle बोलते हैं. Sphere is ideal particle, right? So which has a surface area. Sphere का surface area होता है pi d square, pi d square, and volume of sphere is nothing but the 1 by 6 into pi d. Now what is meant by specific surface? Okay. For particle to be measured, surface area is nothing but the, you know, what is meant by specific surface? So it is nothing but the specific surface is nothing but the surface area divided by, we have already seen this. So for for a sphere, shape factor is nothing but the 6. So what do you mean by particle numbers? We have seen number of particle per unit weight. So it is very important, number of particle per unit weight. It is given in terms of volume number or mean diameter. So particle number is equal to 6 divided by pi d cube, volume number or volume or mean diameter, into this rho. Rho means porous, rho means density. So particle number is equal to 6 divided by pi d cube into density. So different shapes of powder we have seen: tetrahedron, cubical, cylindrical, conical shape, spherical shape, and octahedron. We have already seen this in the last session. We have seen the how to characterize the particle. So particle size is there, particle volume is there. Okay, so particle size may be described, because most of the pharmaceutical powders will have irregular particles, so that's why they are described in comparison with the sphere. So surface diameter means diameter of sphere having similar surface area as that of the asymmetric particle. Okay, then we have seen the volume diameter means diameter of sphere having same volume as that of the asymmetric particle. Then projected area diameter means diameter of the sphere having same surface area as that of the asymmetric particle when observed under microscope. We have seen this. Then Stokes diameter means a diameter of sphere having same sedimentation rate as that of the asymmetric particle. Sieve number means it is nothing but the diameter of sphere which passes through a same sieve number or same mesh as that of the asymmetric particle. Right? Now, volume surface diameter is nothing but the diameter of sphere having same volume to surface area ratio as that of the asymmetric particle. We have seen there are different shapes. We have seen shape factor is nothing but the Okay, shape factor is the ratio of surface area factor divided by volume factor. Surface area factor divided by volume factor. And for sphere, it is a 6. इसके ऊपर क्वेश्चन आ चुका है. If shape factor of particle is more than 6, it is a asymmetric particle, right? So we have seen the characteristic of powder. Powder size. Okay, if uniform particle size is there, known as a mono size powder or monodisperse powder. Okay, and if there is a variation in the particle size in the powder, known as a polydisperse powder. And most of the pharmaceutical powders, they are a polydisperse powder, right? So monocyte powders, they are obtained by either sieving method, and they are monocyte powder are used for the standardization of particle size analyzer. And monocyte powder, how you can get? You can get by sieving method. And then determination of pore size of the filter, effective immunization. So these are the application of monocyte powder. Okay? Then most of the pharma powders are the polydisperse, non-uniform particle sizes. So to describe them, arithmetic mean, geometric mean, harmonic mean, they are used to characterize the powder. Particle size distribution is nothing but the number or weight of particle lying in a particular range. Okay, that is particle size distribution. We already covered this. We also seen these examples, the methods for determination of particle size. We have seen the optical microscopy. In that projected area diameter is there, Martin diameter is there, then Farad diameter is there. Okay, we have already seen in the last session. Again, repeat. We'll see in a different point of view. We have seen the sieving method is also there. Sedimentation method. In that you are going to have Stokes law. Okay, Stokes law, Stokes diameter is measured. Okay. Anderson pipette method is nothing but the method to measurement the particle size based upon the sedimentation method. इसके ऊपर क्वेश्चन बहुत बार आ चुके हैं लास्ट ईयर में आया था we have already seen. We will take next conductivity method also we have completed. The solution, there is solution of sodium chloride or solution of salt is used to make a conductors. Okay, now it is known as a stream counting method, or it is known as a stream scanning method. 4000 particles per second they are counted. इसके ऊपर क्वेश्चन आ चुका है and it is not stable for polar and highly water soluble molecules. Okay, adsorption method. Okay, determination of surface area. Surface area, it can be calculated in academic, calculated simply by particle size data also. Okay, whatever is obtained from above method, जो above method से particle size मिला है आपको, उससे भी आप powder surface area कर सकते हो calculate. But different methods are also there. Adsorption method is there. In that liquid nitrogen is used, which is allowed to adsorb on a powder to form a monolayer at a minus 196 degrees Celsius, and one nitrogen is equal to 16 atoms. Then air permeability method is there. So in this method, the air is allowed to pass between powder. So air is allowed to pass through a powder. So in the powder you have particles, and in between those particles you have capillary. Now that size of capillary decides the, okay. Okay. Now resistance offered by powder to flow that air or to flow the fluid, that is due to the size of powder. Okay, we have already seen. Okay, so in that two type of equations are there. Poiseuille's equation is there and Kozny-Karaman equation is there. Okay, now Fisher substitution is an official instrument which is based upon the air permeability method for measurement of particle surface area. We have seen this. Okay, we have seen this also. We have seen derived properties of powder. Okay, what do you mean by density, what do you mean by porosity, and all that. So these methods, they are very very important, you have to remember. Okay, I will take again after today's session. We have seen the porosity, true volume, bulk volume, void volume, etc, etc. Okay, angle of repose. Okay, we have seen. So angle of repose, what do you mean by angle of repose? So maximum angle maximum angle between surface of pile and powder and horizontal plane. So angle of repose, porosity, density, then Hausner's ratio, then Carr's index, they are the nothing but the determination, that is the determinant for flow properties of powder. So who are the indicator of flow properties of powder? That is the angle of repose, Hausner's ratio, Carr's index. Okay, so flow कब होगा powder? If powder is cohesive, that means if interparticular forces in the powder is higher, so powder is not free flowing. And also interparticular forces depends on the particle size. अगर particle size 10 micron से कम है अगर powder, if particle size of powder is less than 10 micron, so there is a higher cohesive forces, and that's why that powder is not easily flowable. Okay, so angle of repose, again one of the major for flow properties of powder, right? So what is it? So you might have done this practical. So what practical? So you used to take a powder, you used to pour in the funnel, and below you used to give a one paper, and on that this powder will make a pile. Now you used to measure the height and diameter of that. Okay. Now tan theta is equal to h upon r. That is the formula for angle of repose. Right. Now h is nothing but the height of pile, r is nothing but the radius of pile, theta is nothing but the angle of repose. Right. Decrease in the particle size leads to higher or decrease in the particle size leads to increase in the angle of repose. इसके ऊपर क्वेश्चन आ चुका है, लास्ट टाइम मैं बोला. If the particle size is decreased, the angle of repose will be increased. Now, lubricant at low concentration will decrease the angle of repose, and at the higher concentration they will increase the angle of repose. These three lines are very important. So particle size decrease होगा तो angle of repose increase होगा. Fines add मतलब उसमें lubricant add करने at a low concentration, if you add a lubricant, so angle of repose will be decreased, and at a higher concentration angle of repose will be increased. Now fines increases the angle of repose. Now, Car's index is nothing but again one of the major properties, and it is also known as a Car's consolidation index or compressibility index or simply Car's index. So, what is Car's index? Tap density minus pore density divided by tap density into 100. Now, micromeritics we have seen this also. So, we'll see remaining points. So, you can WhatsApp, you can send a message in the group so that other students will join. Right. So porosity, density we have seen. What do you mean by angle of repose we have seen. Remember angle of repose of powder. Okay. So decrease in the particle size will leads to increase in the angle of repose. Lubricants at low concentration will increase the angle of repose. At a higher concentration will decrease the okay. Lubricant at a low concentration will decrease the angle of repose, and at a higher concentration will increase the angle of repose. Now if you add a fine particles to the powder, so that will increase the angle of repose. Car's index is nothing but the tap density minus pore density divided by tap density, go into 100. So ये formula as it is पूछते हैं exam में. So remember the Car's index, also known as the Car's consolidation index, also known as the Car's compressibility index, or simply compressibility index. So what is that? Tap density minus pore density divided by tap density. Alright, we'll see. We have already seen this micrometrics. ये दो तीन बार हो चुका है, इसलिए this also we have seen. Now this is important. So different particle size determination method. So methods for particle size measurement, or methods for particle volume measurement, or methods of particle surface area measurement and particle size range. So by microscopy or by microscopic method, by using microscopy you can analyze particle size in a range of 0.2 to 100 micron. 0.2 माइक्रोन से लेके 100 माइक्रोन तक आपको माइक्रोस्कोपी में you can measure the particle size. Particle size can be measured by microscopy in a range of 0.2 to 100 micron, right? 0.2 to 100 micron. Now in this case, different diameters which are used, diameters are measured. So first one is a projected area diameter is measured. Projected area diameter. Projected area diameter. Projected area diameter. Martin diameter is there, then ferrite diameter is there. They are used. Now diameter, what is the major disadvantage of this method? So whatever particle diameter is measured, that is obtained from only in a two. It is only two dimensions, not only. So not is it is not from three dimensional. So whatever particle diameter you are going to obtain from microscopy, so it is measured by only two dimensional. It is only two dimensional. Now so ordinary optical microscope, you will have less resolution power. Ordinary ordinary माइक्रोस्कोप जो है उसका रेजोल्यूशन जो होता है वो कम होता है, राइट. सो ऑप्टिकल माइक्रोस्कोपी you will get a less resolution, but transition electron microscope or electron microscope will increase the resolution. Transition electron microscope, you can measure particle size in a range of this 0.001 to 0.1 micron. Transition electron microscope, and even by using scanning electron microscope you can measure particle size in a range of 0.01 to 1000 micron. Light microscope or simply optical microscope 1 to 100 micron, right? Now sieve analysis, by sieving method you can measure particle size in a range of 50 to 1500 micron. Now if sieves are photo etched है ना, मतलब है ना, एक पॉलीमर का शीट है आपके पास, उसमें अपन जो मेश होता है वो मेश, सो वो मेश अगर फोटो इचिंग से आया है ना, जैसे एसिड डाल दिया तो इचिंग होता है लाइक वाइट, सो फोटो इच शीव और सीव्स मेड बाय और वट एवर mesh are there, they are made by bombarding the light on that polymer. So photo etched sieve, they can, okay, by using that sieve you can measure particle size in a range of 5 to 95 micron, and they are used, okay, used for grinding of coarse powder. Then by using sedimentation method you can measure a particle size in a range of 0.1 to 300 micron. In this Stokes law is used, and Anderson pipette method is also based upon the Anderson pivot method is also based upon the measurement of particle size by sedimentation method. इसमें क्या होता है कि 550 ml एक cylindrical vessel होता है and 10 ml का pipette होता है, 10 ml का pipette होता है. Now that pipette should be at least 20 centimeter above the 20 centimeter above the in the suspension. Then उसमें 1 to 2% dilute suspension जो होता है वो use करना पड़ता है, and you have to obtain a samples at an interval. I will explain coming slide. वो आएगा अभी. Now temperature range you have to keep in a 10 to 40 liters. Stokes diameter is measured. Now we are going to see the detail. How is the process? Now by using Coulter counter method you can measure the particle size in a range of 0.2 to 500 micron. Now when particle is suspended in the conducting liquid medium containing sodium chloride or salt solution, through, okay, when it is passed through a small orifice, okay, and on either side of this orifice there is a electrodes, okay. Now when sodium chloride solution only passes through that orifice there is a conductance of electricity, okay, but when a particle will pass through that particular orifice, so particle will oppose the conduction, so particle will decrease the conduction, means it will increase the resistance. So whatever resistance is there, you know, up to the electricity, so that is measured, or that is measured as a voltage pulse, and that is amplified and recorded, okay, and which is corresponding to the particle size, okay. For this instrument is there known as a Coulter counter method, okay. Now this instrument is capable for measuring around 4000 particle per second. इसके ऊपर क्वेश्चन आ चुके हैं already, right? So in the Coulter counter method, this instrument, Coulter counter instrument, is able to measure the 4000 particle per second. So it is a very quick method. Now equivalent volume diameter is also measured in this. Particle surface area measurement, इसके ऊपर बहुत बार क्वेश्चन आता है. Which method is used for particle size measurement? Which method is used for particle volume measurement? Which method are used for the measurement of particle surface area? Surface area measure के लिए कौन से मेथड है, पार्टिकल साइज के लिए कौन से मेथड है, पर्टिकुलरली पार्टिकल वॉल्यूम के लिए कौन से मेथड है. पार्टिकल साइज के लिए क्या है, पहला ऑप्टिकल माइक्रोस्कोपी है, देन सेडिमेंटेशन मेथड है. सेडिमेंटेशन मेथड में ही एंडरसन पिपेट मेथड आता है, उसमें और एक दो मेथड आती है अपन देखेंगे, बट एंडरसन पिपेट मेथड इज मोस्ट कॉमनली यूज्ड. कल्टर काउंटर मेथड में क्या है, पार्टिकल वॉल्यूम मेजर करते हैं, याद रखना है, वॉल्यूम प्लस surface area is also measured. Particle volume के लिए Coulter counter method. Okay. Then conductivity method. It is also known as a conductivity method. Coulter counter method or conductivity method. Then third, particle surface area measurement. Now it is done by adsorption measure. Adsorption method. So zero. What is the range? You can measure a particle size in a range of 0.01 to 2000 by using this adsorption method. Now it is given by these scientists Brunauer, Emmett and Taylor. Brunauer, Emmett and Taylor, and it is also in the short form it is known as the BATE equation. Brunauer, Emmett and Taylor. These three scientists, they have proposed the absorption of liquid nitrogen on the powder surface, and they designated one equation known as the BATE equation. They used to ask question like this: BATE equation is related with the particle size measurement or particle surface area measurement by following method. BATE equation is related with the adsorption method. इसके ऊपर क्वेश्चन आता है और आ चुके हैं ऑलरेडी. फिजिकल फार्मेसी बहुत इंपॉर्टेंट है, इसमें जितने चैप्टर है ना वो इंपॉर्टेंट है, उसके ऊपर बहुत सारे क्वेश्चन आते हैं, 6-7 क्वेश्चन इसमें से आते हैं. सो इन द एडसॉर्प्शन मेथड लिक्विड नाइट्रोजन इज अलाउड टू एडसॉर्ब ऑन द पाउडर सरफेस एंड इट इज गिवन बाय दैट इज एडसॉर्प्शन आइसोथर्म, दे आर गिवन बाय बेट, Brunauer, Emmett, Taylor. Okay, that's why BATE equation is related with the particle surface area measurement by using adsorption method. Now liquid nitrogen will form a monolayer on a powder and 1 nitrogen is equal to 16 angstrom. 1 nitrogen का जो molecule होता है that is equal to 16 nitrogen 16.2 angstrom. 1 nitrogen atom is equal to 16.2 angstrom. इसके ऊपर नाइपर में बहुत बार क्वेश्चन आए. Then area diameter as well as the volume diameter is measured in this adsorption method. Right? Now for adsorption method there is one apparatus known as a quantasorb. Known as a quantasorb. Quantasorb is apparatus which is developed by Quantasorb Corporation. Okay. That apparatus is used in the adsorption method. So इसके ऊपर क्वेश्चन आ चुका है. क्वांटासॉर्ब का जो apparatus है उसके ऊपर GPAT 2021 में क्वेश्चन आ चुका है. So I will again explain you. ये अपकमिंग पार्ट में भी फिर से आएगा आपको. Now air permeability method. By using this method you can measure particle size in a range of 1 to 100 micron. Sample is packed into a capillary sample order. Air permeability method क्या है? Air मतलब क्या है? It is a fluid, right? Air is a fluid. Permeability मतलब क्या? Permeability मतलब passing, है ना? To pass or not to pass. Air permeability method. So in this method, what happens? Sample is packed into a particular capillary sample holder, okay, and then air is allowed to pass through that. Now in this you are having powder. So powder nothing but the powder particles, collection of powder particles. In between the powder particle there exists a gap that is known as capillary. Now that capillary, through that capillary the air will move. Now the resistance offered to flow the air, that is nothing but the function of powder particle size and surface area. So resistance of air is the function of particle size. Resistance resistance to flow is a property of particle size. Resistance to flow the air. Larger larger the surface area of particle, larger will be the resistance. Larger surface area of particle, पार्टिकल का सरफेस एरिया ज्यादा होगा तो ऑब्वियसली रेजिस्टेंस भी क्या होगा, ज्यादा होगा. रेजिस्टेंस टू फ्लो द एयर विल बी मोर इफ पार्टिकल सरफेस एरिया इज मोर. नाउ एयर परमेबिलिटी इज इनवर्सली प्रोपोर्शनल टू द सरफेस एरिया. जितना ज्यादा सरफेस एरिया होगा उतना एयर को परमेबिलिटी क्या होगा, कम होगा, राइट. सो यू हैव टू रिमेंबर. अगेन मैं एकदम शॉर्ट में बोलता हूँ आपको कि डिफरेंट मेथड्स फॉर पार्टिकल साइज मेजरमेंट. Your optical microscopy, then second one is nothing but the sedimentation method. In that you have Anderson pipette method, right? Now third method is nothing but the particle volume measurement. So that is a culture counter method. It is a method for particle volume as well as particle diameter. Diameter भी के लिए भी measure करता है ये volume. Now culture counter method or conductivity method. So it is method for particle diameter also and particle volume also. Means particle size also and particle volume also. Particle size के लिए दो मेन मेथड है आपका, ऑप्टिकल माइक्रोस्कोपी एंड कंडक्टिविटी मेथड. ऑप्टिकल माइक्रोस्कोपी एंड सिविंग मेथड एंड देन सेडिमेंटेशन मेथड. तीन मेथड होता है आपके पार्टिकल साइज मेजर के लिए. सिर्फ पार्टिकल साइज पहला होता है आपका ऑप्टिकल माइक्रोस्कोपी, दूसरा होता है आपका सिविंग मेथड, तीसरा होता है आपका सेडिमेंटेशन मेथड. सेडिमेंटेशन मेथड है एंडरसन पिपेट यूज करते हैं, ठीक है. और एंडरसन पिपेट मेथड इज मेथड बेस्ड अपॉन द सेडिमेंटेशन. उसमें स्टोक्स लॉ इन्वॉल्व है, उसमें स्टोक्स डायमीटर मेजर करते हैं. ऑप्टिकल माइक्रोस्कोपी में आपका प्रोजेक्टेड एरिया डायमीटर मेजर करते हैं, उसमें मार्टिन डायमीटर भी आता है, फेरेट डायमीटर भी आता है ना. सीविंग मेथड में सीयू डायमीटर ही मेजर करते हैं, है ना. सेडिमेंटेशन मेथड में सेडिमेंटेशन डायमीटर मेजर. Now culture counter method is used for the measurement of particle size, that is size also and particle volume also. Now particle surface area measurement is done by adsorption method and air permeability method. क्वेश्चन आपको ऐसा आता है, फॉलोइंग मेथड्स आर एम्प्लॉयड फॉर द मेजरमेंट ऑफ पार्टिकल सरफेस एरिया. तो क्या है, एंडरसन पिपेट मेथड, सॉरी एडसॉर्प्शन मेथड एंड एयर परमेबिलिटी मेथड. तो एयर परमेबिलिटी मेथड एंड एडसॉर्प्शन मेथड, ओके. और क्वांटासॉर्ब apparatus इज यूज्ड. क्वांटासॉर्ब apparatus, ये जो दो मेथड है, एयर परमेबिलिटी मेथड एंड एडसॉर्प्शन मेथड, they are the method for measurement of particle surface area. Culture counter method, particle size as well as particle volume. Culture counter method is also known as a conductivity method. Optical microscopy, sieving method and sedimentation method. So first three are for particle size measurement. This is a for particle size as well as volume measurement, and these two are for particle surface area measurement. Porosity क्या होता है? Porosity is nothing. Porous मतलब क्या है? Porosity means particle. Okay, a powder having high bulk volume. Okay, porosity means high bulk volume. High bulk volume. High bulk. Because bulk volume means what? So if you take a sample of powder, 5 ग्राम पाउडर ले लो आप, एक मेजरिंग सिलेंडर में डाल दो, उसका वॉल्यूम चेक करो कितना है. Now that is nothing but the bulk volume. So if you take a powder, if you measure the volume of powder in the measuring cylinder, and that volume is nothing but the bulk volume. Now in that bulk volume जो particles है powder के, तो वो particle जो है ना particle, तो उसमें कुछ space रहता है. In between two particles there is some space, known as interparticular space, or also known as a void or void. Okay, so true. So volume. So bulk volume is nothing but the okay okay volume of powder is nothing but the bulk volume minus true volume. Okay, actual volume of powder is nothing but the bulk volume minus true volume. Now bulk volume is without tapping, right? So bulk volume consists of a wide volume plus interparticular spaces. Bulk volume consists of a wide volume plus interparticular spaces. Now true volume is only interparticular space. Okay? So porosity is nothing but the ratio of wide volume to the bulk volume. Ratio of wide volume to the bulk volume. Bulk density means what? Bulk density means simply a true density plus wide volume. True density क्या होता है? Simply mass upon volume. Mass upon volume. Density. Bulk density means true density plus wide volume. Now mass of powder by divided by bulk volume. That is a bulk density. In reference to a bulk density, there are two terms. Term light. Light means क्या? Light powder. Light powder means low bulk density. A term light powder means a powder is having low bulk density. Question इसके ऊपर आ चुका है. Term heavy powder means the powder is having high bulk density. Heavy powders or light powder. आप बोलते हो ना light kaolin, heavy kaolin. तो मतलब क्या आता है? Light kaolin means it has a less bulk density और low bulk density. तो वो पाउडर थोड़ा लाइट होता है ना. दो पाउडर है आपके पास लाइट है ना, लाइट ये है ना, लाइट पाउडर है और एक हेवी पाउडर है. तो वो अगर अपने एक ही ग्राम है, दोनों भी सेम क्वांटिटी है. सो 1 ग्राम लाइट केवलिन if you pour in the measuring cylinder, so you will get a volume of 6 around, for example 6 centimeter. And if you pour a heavy kaolin, 1 gram heavy kaolin in the measuring cylinder, you will get a volume of only 4 centimeter. So that extra 2 centimeter is nothing but because of the voids. That's why light powder means having high bulk volume. Light powders will have high bulk volume and heavy powder will have less bulk volume. So light powder is nothing but the more porous powder. True density क्या होता है? True density is nothing but the volume of material divided by its mass. Okay, that is the true volume. And then granular density मतलब क्या है? Ratio of mass of granular powder divided by volume of granule mass divided by volume, simply granular density. Right? Now bulkiness मतलब क्या? Bulkiness is nothing but the bulkiness will increase with the decrease in the particle size. And types of density again. What is the true density? We have told you mass upon true volume. Now how to calculate the true volume? Because bulk volume जो होता है उसमें interparticular space plus void volume. True volume is bulk volume minus void volume. That is a true volume. And mass upon true volume is a true density. Now true density is measured by this helium cyclometer. Helium cyclometer. Okay, for porous solid. Again, liquid displacement method is also there for non-porous solid. अल्कोहल डिस्प्लेसमेंट जो voids रहता है, जो स्पेसेस रहते हैं इन बिटवीन पार्टिकल, void तो इसमें नहीं रहता लेकिन इंटर पार्टिकुलर स्पेस रहता है, तो उसमें जो हीलियम है क्या से हीलियम गैस, सो वो वहां पे जाके अटक जाता है ना. सो इट विल ऑक्युपाई द एम्प्टी space between the particle, interparticular spaces that will be occupied by helium or it will be occupied by liquid. So that's why for measurement of true density, helium psychrometer or helium gas displacement method, or then liquid displacement method. These are the method used for the measurement of true density. Question आ चुका है इसका. Now, how you can measure the granularity? By using mercury displacement method. इसके ऊपर 2 बार क्वेश्चन. So granule density is measured by mercury displacement method. Right? Now, bulk density is measured by simply, है ना, कैसे मेजर करते हैं bulk density? So graduated cylinder जो होता है आपका measuring cylinder based upon tapping from 1 inch. तो 3 taps करना है. So you have to take for example 1 gram, sorry 1 gram तो कम हो जाए, 5 gram पाउडर ले लिया आपने measuring cylinder में, है ना, और उसको उसको क्या करना है फिर 1 इंच से you have to, okay, you have to tap on a wooden okay, wooden table. You have to tap on a wooden table from 1 inch 3 times in a 2-minute interval. That is known as a 3-tap powder. 3 tap. Okay. Now in some pharmacopoeias you have 500 taps also. Okay, 500 taps also. So 3 tap or 500 taps. So then you have to measure the density. That is known as a bulk density. Bulk density is simply measured by measuring cylinder. Now density, okay, definition, उसका formula, how to determine the density and उसके ऊपर comment. So first one is nothing but the bulk density. So bulk density is denoted by rho b. Rho मतलब density, b मतलब bulk density. So rho b मतलब bulk density. Now what is the definition? Simply mass divided by bulk volume. Mass divided by bulk volume. What is the formula for bulk density? So bulk density is equal to mass divided by bulk volume. Okay, determination of bulk density. There is nothing but the bulk density apparatus is there known as psychrometer. Right? Psychrometer or helium, simply helium. Now, it is a characteristic of powder depends on the particle packing as the powder consolidate. तो पार्टिकल में पैकिंग कैसा हो चुका है पाउडर में पार्टिकल का, उसके ऊपर डिपेंड करता है bulk density. Now granular density, so granular density is determined or it is denoted by rho g. Rho g. It is nothing but the mass of granules divided by granule volume. And granular density is equal to mass divided by granule. Now it is measured by or it is determined by, it is measured by mercury displacement method. क्वेश्चन इसके ऊपर आ चुके हैं, मैंने इसे बोला. Now true density is denoted by rho t. Rho t, this symbol is known as rho. Mass divided by true volume. Rho t is equal to mass divided by true volume. Now it is measured by helium densitometer or helium psychrometer. तो helium displacement method करते हैं उसको. And again it is for porous powder and for non porous powder liquid displacement method is there, है ना. तो एक बुक में कुछ नहीं होता है, 4-5 बुक पढ़ना पड़ता है. It is a characteristic of particle. Then tap density. Tap density is known as a rho t. Rho t. Mass divided by volume obtained by compacting the bulk volume by tapping. मतलब क्या है, तो नॉर्मली आपने सिलेंडर में पाउडर लिया था तो उसका अगर वॉल्यूम 6 सेंटीमीटर है तो बाद में जब टैप किया आपने 3 टैप और 500 टैप तो उसका वॉल्यूम कम हो गया ना. Now that density is known as a true density. Or so that density is known as a tap density. Okay. So determined by mechanically tapping device, okay, or simply by using your okay, simply by using your cylinder used to characterize the powder. Okay. So these are the different types of density. Are you understanding? Are you getting different type of density? है ना, डेंसिटी कितने टाइप को, क्योंकि इसके ऊपर क्वेश्चन आता है इंपॉर्टेंट है. बल्क डेंसिटी, ग्रैनुलर डेंसिटी, ट्रू डेंसिटी, टैप डेंसिटी, मेथड्स फॉर मेजरमेंट ऑफ दिस डेंसिटी, है ना. क्वेश्चन इसके ऊपर आता ही आता है. कार्स इंडेक्स हो या ऑलरेडी सीन. कार्स इंडेक्स इज नथिंग बट द tap density minus pore density by tap density into 100. It is also known as a Car's consolidation index or simply Car's index or simply compressibility index. Now Car's index is one of the indicator for flow properties of powder. Car's index क्या है? It is indicator for flow properties of powder. So if Car's index is in a particular range of, that is okay, so यहाँ पे दिया है कार्स इंडेक्स. So this table is again important. Cars index or percent compressibility or simply cars consolidation index. So and type of flow. So if cars index of powder is between this 5 to 15, the cars index जो है powder का 5 to 15 आता है, so that means the powder is excellent or free flowing. If cars index of powder is between 12 to 16, then it is a good flowing. If cars index of powder is between 18 to 21, it is a fair flowing. If it is between 20 to 23 to 28, then it is a poor flow, or you can say possible. Now 28 to 35, अगर cars index अगर 28 to 35 है, so it is a poor flowing powder. If it is between 35 to 30, 38, then very poor powder or fluid cohesive. And if cars index is more than 40, if cars index of powder is more than 40, then extremely poor flowing powder, or that is a cohesive powder. तो फिर से देखो, and cars index if cars index of powder is between 5 to 15, then excellent flowing. If it is between 12 to 16, good flowing. If it is between 18 to 21, fair flowing powder. Well, then if it is between 23 to 28, poor or possible. Then if it is between 28 to 35, definitely poor. Then 35 to 38, very poor or fluid cohesive. More than 40, extremely poor or cohesive powder. ये कार्स इंडेक्स का relation with the flow. Now Hausner's ratio is nothing but the tap density divided by bulk density. Tap density divided by bulk density, that will give you Hausner's ratio. And now Hausner's ratio is again one of the measure for flow of powder. Now if Hausner's ratio is less than 1.25, अगर हाउसनेस रेशियो 1.25 आता है पाउडर का, if it is less than 1.25, if हाउसनेस रेशियो of a powder is less than 1.25, that indicate the good flow of powder ना. अगर पाउडर का हाउसनेस रेशियो एक एक 1.25 से कम है, तो मतलब वो पाउडर का है गुड फ्लोइंग. if हाउसनेस ratio of powder is between 1.25 to 1.5, it is a moderate flowing. if हाउसनेस ratio is more than 1.5, it means poor flowing of powder. ठीक है, तो हाउसनेस रेशियो भी इंपॉर्टेंट है. हाउसनेस रेशियो तो इजीली याद रखता है, यू कैन इजीली रिमेंबर द हाउसनेस रेशियो. इसमें दो ही वैल्यू है ना. सो इफ हाउसनेस रेशियो ऑफ पाउडर इज लेस देन 1.25, it is a good flow. If it is between 1.25 to 1.5, so moderate flow. If it is more than 1.5, poor flow. That's it. Now angle of repose again is one of the measure for flow properties of powder, right? So we have seen how to measure the angle of repose. So you have to make, you know, you have to take a particular weight of powder and pour that powder in a funnel, okay? And below the funnel you have to keep a paper. On that you will get a pile. On that you will get a pile. Now you have to measure the height of that pile and diameter of that pile. Now tan theta is equal to h upon r. Now if angle of repose of powder is less than 25, you are going to have excellent flow. If angle of repose is of a powder is between 25 to 30, that is known as a good flow. If angle of repose of powder is between 30 to 40, it is a possible flow. And if it is more than 40, it is known as a very poor flow or cohesive powder or cohesive powder. तो एंगल ऑफ रिपोज भी इजीली याद रख सकते हो. थोड़ा सा कार्स इंडेक्स में ही थोड़ा सा कंफ्यूजन हो सकता है आपको, बाकी हाउसनेस रेशियो एंड एंगल ऑफ रिपोज बहुत ही इजी. तो एंगल ऑफ रिपोज और एक बार देख लो. So if angle of repose of powder is less than 25, excellent flow is there. If angle of repose of powder is between 25 to 30, good flow is there. If angle of repose of powder is between 30 to 40, it is a possible. And if angle of repose of powder is more than 40, it is a very poor flow. Are you getting or not? समझ रहा है? Again you can see over here same thing. दो तीन बार पढ़ लो, थोड़ा सा इजीली याद हो सकता है. Flow okay. And now if cars index, okay, if cars index of powder is between 5 to 15, it is an excellent flow. If cars index is between 12 to 16, good flow. 18 to 21, fair or possible. 32 to 33, 23 to 35, poor flow. Cars index of powder is between 33 to 38, very पुअर फ्लो, मोर देन 40 कोहेसिव पाउडर, है ना। अलग अलग बुक में अलग अलग थोड़ा सा वैल्यू दिया है, तो कंफ्यूज है आप, ऐसा नहीं बोल सकते अपन कि ये बुक गलत है वो बुक गलत है। ये एवरेज होता है ना। एवरेज रेशो भी यहाँ पे बहुत सारा दिया है, इतना ज़्यादा याद तक रखने की जरूरत नहीं है आपको, जब मैंने पहले स्लाइड में दिया था। इफ हाउसनेस रेशियो इज लेस देन 1.25, है ना, poor flow. If it is between 1.5 to 2.5, then okay, more than 2.5, poor flow. Below the 1.25, excellent flow is there. So if Hausner's ratio of powder is less, okay, in between 1.05 to 1.8, it is a excellent flow. If it is between 1.14 to 1.2, it is a good flow. If it is between 1.2 to 1.26, it is a passable. If Hausner's ratio is between 1.3 to 1.54, it is a very flow. Very it is a poor flow. If Hausner's ratio of powder is between 1.5 to 1.6, it is a very poor flow. And if it is more than 1.67, it is a very poor flow. So let's say, for example, compressibility characteristic of few pharmaceutical powders they have given over here. So for example, material is nothing but the cellulotype. Cellulotype मतलब cellulose derivative होता है. Percent compressibility of this cellulotype is nothing but the 11%. So that means what is its flowability is excellent. So percent compressibility of N-compress. N-compress क्या है? N-compress is the trade name of pharmaceutical diluent. So उसमें 15% compressibility है. It is again excellent. Star RX 1500. ये क्या है? डायरेक्टली कंप्रेसिबल स्टार्च होता है. ये क्या है? डायरेक्टली कंप्रेसिबल स्टार्च होता है. 19% compressibility is there. So flowability is a fair possible. Lactose has a 19% compressibility, which is a fair again possible. Now maize starch उसका होता है 26 to 26.7. It is a poor flowing. देखो starch का पाउडर जो होता है वो free flowing नहीं होता है. That is a poor flowing. Magnesium stearate has a percent compressibility. That is a Car's index. It is a 31. So it has a poor flow. Titanium dioxide 34 होता है उसका, तो वेरी पोर फ्लो. एंड डाइकैल्शियम फॉस्फेट 41 होता है, वेरी पोर फ्लो. टाल का होता है 49, है ना. तो इसके ऊपर को एक बार क्वेश्चन आया कि विच ऑफ द फॉलोइंग पाउडर इज वेरी पुअरली फ्लोइंग. तो टाल का जो है ना, इट हैज अ वेरी पुअर फ्लो. इट हैज अ कार्स इंडेक्स 49. दैट्स व्हाई याद रखना है आपको ये थोड़ा सा. नेक्स्ट विल सी. Now on this slide I have extracted this information today only, and ये बुक में भी नहीं है ना. बुक में बाकी का जो मटेरियल है उसको बुक में है. Now different methods and procedure. क्योंकि प्रोसीजर उतना इम्पोर्टेंट नहीं था इसलिए वो लिया नहीं था, बट यहाँ पे प्रोसीजर भी इंक्लूड किया है शॉर्ट में. So I have included procedure also in a short, and then advantages and disadvantages. Yesterday only I told you advantages, disadvantages are not important, but again I have extracted very short. तो पहला मेथड कौन सा है आपका? to measure the particle size. First method is nothing but the optical microscopy, and you can measure the particle size in a range of 0.2 to 100 micron. Now in this, okay, in this method, the particle number distribution data can be obtained, and it can be converted into weight distribution data. Now in this method, what you have to do? Suspension, you have to make suspension or suspension of powder or emulsion. Either it may be either diluted or undiluted. You have to mount on the slide. Microscope जो होता है उसकी slide में mount करना है. And your eyepiece जो होता है, eyepiece, it is fitted with the ocular which is calibrated with the stage micrometer. मतलब उसमें आपको calibration देगा, उसमें आपको calibrated. Now the field can be projected on the screen, and particles are measured more accurately, and from that you can take a photograph also. है ना. आपको क्या करना है? एक माइक्रोस्कोप लेना है. माइक्रोस्कोप के यहाँ पे सस्पेंशन बनाना है, तो उसको ड्रॉप डालना है किसके स्लाइड के ऊपर. और जो आपका आईपीस है वो कैलिब्रेटेड होना चाहिए इन टर्म्स ऑफ योर स्टेज माइक्रोमीटर, है ना. बाद में क्या करना है, आप जो आपको आईपीएस में दिख रहा है वो भी आप थोड़ा सा प्रोजेक्ट भी कर सकते हो, बड़ा इमेज भी देख सकते हो, जैसे आपने स्टोमेटा मेजर की होगी, so likewise that only. Okay, and then you can measure a particle in a particular slot. Okay, that is the optical microscopy. Now it is used to measure the particle size in a suspension, emulsion and aerosol. What is the use of optical microscopy? To measure the particle size in the suspension, emulsion and aerosols. Now to get a valid result, if you want to get a valid result, you have to measure at least 500 to 1000 particle. तो 500 से लेके 1000 पार्टिकल मेजर करना है. Okay, so to get a valid result, 500 to 1000 particles are measured for every sample, and from this data you can get a frequency distribution curve and cumulative frequency distribution curve. They can be plotted. What are the advantages of this optical microscopy? Advantages क्या है इसके? So direct observation of size and shape of powder is possible. Now you can also project and take a photograph of that powder. Okay. Now if aggregation of powder is there, if any, it is easily detected. अगर particles में agglomeration aggregation होगा तो वो भी दिखता है आपको. It is a very simple method, economic and easy to handle, right? Okay, disadvantage क्या है इसका? Disadvantage, you can see particle only in a 2 dimension. ना उसका लेंथ देख सकते हो आप, उसका है ना, लेंथ देख सकते हो, उसका विड्थ देख सकते हो. So only 2 dimensional, that is length and breadth or width, length and width, but no depth. So थर्ड जो होता है एक्स वाई एंड जेड, तीन तीन होते हैं ना आपका एक्सिस, एक्स एक्सिस वाई एक्सिस एंड जेड एक्सिस. So 2 dimension means only x and y axis. So powder, okay, particle which is under the microscope, you can observe only x and y axis, its length and width, not है ना, not height or depth. Depth or height नहीं measure कर सकते. So particle only 2 dimension is there. Okay, only 2 dimensional diameter is a length and width and not depth. Slow, the method is very slow and time consuming and tedious because you have to measure at least 3000 to 5000 particles to get a correct distribution. Okay. That is the disadvantage. Are you getting or not? समझ रहे हैं? Now second method होता है sieving method. Sieving method. In this method, you can measure the particle size in a range of 50 to 1500 micron. Now, in this different sieves are used. We have seen this in the size separation. Size separation में देखा है अपने sieve number 10, sieve number 20, so size वगैरह, mesh aperture वगैरह. Now these sieves are the calibrated by National Bureau of Standard (NBS). Sieves, they are known as mechanical sieves, which are calibrated by National Bureau for Standard. Now, photo etched or electroformed sieves are also available. Okay. The method gives directly the weight distribution, and it's useful in the method. The method is useful in the development of tablet and capsules. Now sieves are arranged in the descending order of their mesh size. मतलब क्या कि जैसे sieve नंबर 10 है, उसका mesh size क्या है? बड़ा है. sieve नंबर 10 जो होता है वो coarse sieve है ना, coarse. उसके बाद में sieve नंबर है ना, sieve नंबर 20, sieve नंबर 25, sieve नंबर 25, sieve नंबर 30, sieve नंबर 40, sieve नंबर 60, 80, 120. तो ऐसे आपको अरेंज करना है. So the sieve having coarse mesh aperture should be kept first, and after that, decreasing the uh, decreasing the mesh aperture. So sieves are arranged in the descending order. There is at least 5 sieves you have to arrange. Okay, then 50-gram sample you have to place on that sieve. Now there is one instrument known as a mechanical sieve shaker that might be present in your laboratory also. Now it is operated for 15 to 20 seconds and retain powder on each sieve. मतलब है ना 10 के बाद में आता है sieve नंबर 25, उसके ऊपर कितना पाउडर रिटेन हो गया. उसके बाद में नीचे आता है sieve नंबर 40, उसके पास उसके वहाँ पे कितना पाउडर रिटेन हो गया, या फिर उसके बाद में 80 आता है, 80 के ऊपर कितना रिटेन हो गया, वो आपको कलेक्ट करना है एंड वे करना है. So you have to collect and weigh retain powder on the sieves. Now, obtained data is analyzed for powder normal or log normal or percent okay, frequency distribution curve. Normal frequency distribution curve or log normal frequency distribution curve or percent frequency distribution curve. So whatever data is obtained. Now what are the advantages of this method? Method के advantage क्या है? Is very simple, inexpensive, and provides a reproducible result. Useful for weight distribution and can be used for the size up to 5 micrometer. Disadvantage क्या है? Limited lower sieve limit is there. Less than 5 micrometer नहीं कर सकते आप. Dried sample is required and you have to dry sample during each measurement. Now clogging of sieves may occur during the violent shaking of sieves. Attrition may cause error in the measuring and it is also time consuming. So these are the advantages and disadvantages of your sieving method. I hope you are getting. समझ रहा है आपको? Now sedimentation method है आपका. For this way, sedimentation is useful for the measurement of particle size in the suspension, emulsion and determination of molecular weight of polymer also. In this, Stokes law is involved and Stokes diameter is measured. So in this sedimentation method, there are different methods. Sedimentation method में भी Anderson pipette method एक होता है और इसको simply pipette method भी बोलते हैं. And it is mostly used method under this sedimentation. Then another method is there known as the hydrometer method. Hydrometer method, and another method is known as a balance method. So there are three methods in the sedimentation method. Particle size measurement by sedimentation involves the three methods. What are the three methods? First one is a pipette method, second one is a balance method, and third one is a hydrometer method. Okay. So out of that, pipette method, that is the Anderson pipette method, is most commonly used. Now what is Anderson pipette method? It is a measurement of particle size by sedimentation. So in this you have one vessel known as a 550 ml vessel. 10 ml pipette is there, which is sealed into a ground glass top. Now lower tip of this pipette should be is 20 centimeter below the surface of the suspension. मतलब जब आप वेसल है ना, ऐसा कुछ वेसल है, इसमें क्या है, पिपेट है, पिपेट, इसमें सस्पेंशन है. और ये पिपेट जो है ना एटलीस्ट 20 मीटर होना चाहिए, इसके अंदर एटलीस्ट 20 सेंटीमीटर होना चाहिए सस्पेंशन के अंदर, तभी सस्पेंशन क्या होगा, इसमें मूव होगा. और इंटरवल जो है 10 सेंटीमीटर, 5 सेंटीमीटर, 6 सेंटीमीटर, इस इंटरवल पे आपको सैंपल लेना है उसका. ठीक है. Now 1 to 2% suspension of powder is suitable in a suitable medium. You have to prepare and you have to add depopulating agent if required. Then transfer this solution into vessel. Okay. Remove the stopper and attach two-way stopcock. Stopcock. इसमें एंडरसन पिपेट डालना है आपको. बाद में remove the stopper and attach two-way stopcock. Then at a various interval at a various interval you have to take a 10 ml sample and you have to evaporate that sample, and then you have to take a weight of that sample and analyze that sample by different methods. Weight divided by weight or amount of powder is obtained. So weight of powder or amount of powder is obtained at each interval is referred as a weight number, is referred as a weight under size, and then later it is converted into cumulative weight size. That is a sedimentation method. तो याद रखना है, एंडरसन पिपेट के बारे में बहुत बार क्वेश्चन पूछा है. There is a method for measurement of particle size by sedimentation method. थर्ड मेथड होता है आपका पार्टिकल वॉल्यूम मेजरमेंट के लिए, that is nothing but the Coulter counter method. Now this apparatus measures the 4000 particles per second. This apparatus measures the 4000 particles per second. Now what type of information? So it gives the number distribution. It gives the number distribution, particle number distribution, particle volume is measured, and later it is converted into particle diameter. Now it is useful in the study of particle growth in the suspension and solution. Coulter counter method क्या है? Useful in the study of particle growth in the suspension and solution. Also useful is the study of effect of antibiotic on the microorganism. This culture counter method is quick and accurate. ये जो culture counter method होता है, it is a quick and accurate. It gives accurate result. Particles, okay, the particles are suspended in a liquid containing salt, that is sodium chloride, which is used as a conducting medium. तो इसके ऊपर भी क्वेश्चन आया है, which salt is used in the culture counter method? Sodium chloride. Now, now it is passed through. It is passed through a small orifice. The solution is passed through small orifice. Maintain a contact with the. It is a maintained with the. It is the that orifice is maintained in contact with the external environment to measure the conductance. To measure the conductance. Okay. ये part थोड़ा सा additional part लिया है मैंने. So in this method, what you have to do, you have to prepare a solution of powder, or you have to prepare suspension of powder in a salt, a conducting medium, and you have to pass that solution through a small orifice which is maintained. Okay, the orifice is maintains a contact with the external environment to measure the conductors. तो जो external है उसमें ये रहेगा, क्या रहेगा, electrodes, positive and negative electrodes. Now diluted suspension is the suspension should be diluted in a such a manner that only one particle should, or only one particle can pass through the orifice at a time. मतलब जो सस्पेंशन बना रहे हैं आप पाउडर का इन द सोडियम क्लोराइड सोल्यूशन में जो पाउडर का सस्पेंशन है, वो सस्पेंशन इतना डाइल्यूट होना चाहिए कि एक टाइम पे वो ओरिफिस में एक ही पार्टिकल जाना चाहिए. डाइल्यूट, okay, so you have to dilute the suspension so that only one particle can pass one time through orifice. Now current is applied across the electrodes. Now when salt solution, only salt solution is passing, है ना, solution जा रहा है through the orifice. Now between these, you know that salt solution is a good conductor of electricity, so it produces, okay, it will not produce any resistance, it will only give conductance. But suppose particle, when particle comes to the orifice, now at that time particle have a different conductivity, so it will not have same, so it will have less conductivity, that means it will have some kind of resistance, so it will produce a resistance. This change in the resistance is measured and related to particle volume. It causes the voltage pulse, which is amplified and recorded by the pulse height analysis in terms of particle size. That's how you can measure the particle size and particle volume by using culture counter method. Now advantage is it is a very fast, accurate results can be there. It can be used for the measurement of particulate contamination in the parental product. The model count, okay, model counter M4 एक model है counter M4 model. So it can measure the particle size in a range of 0.02, 0.03 to 0.3 micron. It is used for the study of clustering process. Okay, जब क्रिस्टलाइजेशन बनता है तो क्लस्टरिंग कैसे होता है उसका स्टडी करने के लिए भी पार्ट ये कल्चर काउंटर मेथड यूज कर सकते हैं. एंड आल्सो यूज टू स्टडी द पैकिंग ऑफ मिनरल्स इन द रिनल स्टोन. जो किडनी में स्टोन होता है उसमें कैसे पैकिंग हो रहा है कैल्शियम सिट्रेट का, कैल्शियम यूरेट का, तो वो स्टडी के लिए भी करते हैं. डिसएडवांटेज क्या है, इट इज नॉट स्टेबल फॉर द पोलर एंड हाईली soluble material due to solution effect, and it is an expensive method. This is the all about the culture counter method. culture counter method, ये डाटा सब कुछ एक्सट्रैक्ट करके बुक में से यहाँ पे है. These things you will not find in English book. बाकी जितने भी जीपैट के बुक्स हैं इनमें इतना डाटा मिलेगा ही नहीं आपको किसी की बुक में. कौन सा बुक लेके आओ, सरफेस एरिया मेथड ना. कलर करने से बुक को कलर करने से कोई फर्क नहीं पड़ता. डाटा होना चाहिए उसमें और मेन डाटा होना चाहिए. कलर सिर्फ डायग्राम डाल के कुछ फायदा नहीं, वो तो आपको रेफरेंस बुक में मिल जाएगा ना, तो आपकी बुक का फायदा क्या है फिर ना. तो ये इम्पोर्टेंट है समझना. बच्चों क्या लगता है, कलर है चलो भागो, कलर बुक आए तो भागो. लेकिन उसका यूज क्या है, उसमें कंटेंट कितना है, डायग्राम भर के पड़े पूरे, वो यूजफुल नहीं है. कंटेंट इज इम्पोर्टेंट। जैसे मैंने यहाँ पे लिखा है कि एयर परमिटिविटी मेथड, उसमें दो इक्वेशन लिखे, पोजलीज इक्वेशन, कोजनी-कैरामन इक्वेशन, बोल्ड में लिख करके रखा है कि आपको फटक से क्लिक होना चाहिए। कोजनी-कैरामन इक्वेशन इज रिलेटेड विद द पार्टिकल सरफेस एरिया मेजरमेंट बाय एयर परमिटिविटी मेथड, है ना। तो उसमें ये सब नहीं दिया हुआ, तो ये इंपॉर्टेंट है कि कंटेंट इंपॉर्टेंट। नाउ सरफेस एरिया मेजरमेंट, मेजरमेंट ऑफ सरफेस एरिया ऑफ पार्टिकल। सो स्पीयर हैज अ मिनिमम सरफेस एरिया पर यूनिट वॉल्यूम। स्पीयर में क्या होता है, राउंड सर्कुलर पार्टिकल जो होता है उसमें मिनिमम सरफेस एरिया होता है पर यूनिट वॉल्यूम। और सरफेस एरिया ऑफ पाउडर कैन बी कैलकुलेटेड बाय यूजिंग पार्टिकल साइज डाटा। ओके, नाउ व्हाट इज शेप फैक्टर? Shape factor is nothing but the 6 for sphere. Specific surface area is important in the flow and packaging of powder in the packaging of particles in the packaging properties of part. Now, what is meant by specific surface? Specific surface is nothing but the surface area divided by weight. Surface area of a unit weight. Surface area divided by, okay. Specific surface is nothing but the surface area of a unit weight or volume. Now, adsorption method, इसमें दो मेथड होता है measurement of particle surface area by two methods. Adsorption method, in this liquid nitrogen is allowed to adsorb on the powder. Liquid nitrogen at a minus 196 minus 196 degrees Celsius, minus 196 degrees Celsius is allowed to adsorb on the powder to form a monolayer. Now one nitrogen atom is equal to 16 angstrom unit. जैसे मैंने बोला इसके ऊपर क्वेश्चन आ चुका है उसका। There is one apparatus known as a contour. There is one apparatus known as a contour. इसके ऊपर GPAT 2021 में क्वेश्चन आए, which sorry GPAT 2022 में क्वेश्चन आए। Contour is the apparatus used to measure the particle surface area. Contour by adsorption method, है ना। Particle surface area measurement by adsorption method. The apparatus used is a contour. इसके ऊपर क्वेश्चन आ चुका है। Now contour apparatus manufactured by Contachrome Corporation is used to measure the surface area and porous structure of powder. यहाँ पे कम से कम 2-3 क्वेश्चन ऑलरेडी इसमें कवर हो चुके हैं। सेकंड मेथड होता है एयर परमेबिलिटी मेथड। इट इज आल्सो यूज्ड टू कंट्रोल द बैच टू बैच वेरिएशन इन द पार्टिकल साइज रेजिस्टेंट टू द फ्लो ऑफ अ फ्लूइड लाइक एयर थ्रू कैपिलरीज इन अ प्लग ऑफ पाउडर इज द सरफेस एरिया ऑफ पाउडर, है ना। सो जितना ज़्यादा रेजिस्टेंस होगा उतना ज़्यादा सरफेस एरिया, greater will be the resistance, greater will be the surface area per gram of powder. Now by using, there are two equations, Poiseuille's equation. By using this you can get a particle size, and by using Kozni-Karaman equation you can get a surface area. Adsorption method में यहाँ पे याद रखना है कि Bate equation is involved, Brunauer, Emmett and Taylor equation. Bate equation is there, which is nothing but the adsorption isotherm for nitrogen on a powder to form a monolayer. Bate equation, Brunner, Emmett, Taylor. तो उसके रिलेटेड ये इक्वेशन है, ये भी याद रखो, क्वेश्चन उसके ऊपर भी आ चुका है। Poiseuille's equation and Kozni-Karaman. So Poiseuille's equation determines the diameter of the capillaries between powder particle. Kozni-Karaman equation relates the surface area of powder. Now there is one official machine, or there is one official apparatus known as a Fisher subsidizer. Fisher subsidizer is an apparatus used for the measuring of particle size by air permeability method. Air permeability method. Advantages क्या है इसके? Advantage simple है instrument, simple instrument है. There is a high speed of measurement. It is widely used for the measurement of specific surface area. Okay. Then there is a Bepinium hydronephrate drug is there. Bepinium hydronephrate. So it is standardized by using this, okay, air permeability method. Or the surface area of Bepinium hydronephrate powder, BPC, British Pharmacopoeia Codex, is standardized by this method. Specific surface area of griseofulvin is measured by this method, which is officially in the USP, United States Pharmacopoeia. Measuring the fineness of cement is also done by using this. Fineness of cement is also done by this method, adsorption method. तो adsorption में दो मेथड है, याद रखना है आपको। सॉरी, For the surface area measurement, you have two methods. First is the adsorption method and second is the air permeability method. क्वेश्चन इसके ऊपर आ चुके हैं बहुत बार. तो क्वेश्चन आएगा आपको कि फॉर मेजरमेंट ऑफ पार्टिकल साइज फॉलोइंग मेथड्स आर यूज्ड. क्वेश्चन ऐसा पूछेंगे और उसमें एक आधा ऑप्शन देंगे आपको, है ना, एयर परमेबिलिटी मेथड या फिर एडसॉर्प्शन मेथड ऐसा. तो एडसॉर्प्शन एयर परमेबिलिटी इज फॉर मेजरमेंट ऑफ पार्टिकल सरफेस एरिया नॉट साइज. साइज के लिए क्या है कि ऑप्टिकल माइक्रोस्कोपी है, सीविंग है, आपका सेडिमेंटेशन मेथड है. वॉल्यूम के लिए क्या है कि वॉल्यूम के लिए कल्टर काउंटर मेथड है. वॉल्यूम एंड साइज दोनों के लिए कल्टर काउंटर मेथड है ना. और याद रखना है कि पार्टिकल सरफेस एरिया मेजरमेंट के लिए एडसॉर्प्शन मेथड है, एयर परमेबिलिटी मेथड. क्वेश्चन उसके ऊपर आते हैं. सो दिस वाज टुडेज सेशन.